Hello, and welcome to the Geotechnics Laboratory at NTNU. And today we'll go through the extraction procedures related to getting the clay sample out of a cylinder. So here we have a typical cylinder. It's around 90 centimeters long, and typically the drillers will take a sample at 1 meter intervals into the ground. This is a good opportunity to remind you all that this is the top of the sample and this is the bottom of the sample. So this means this is the shallow end and this is the deeper end of the sample. But this particular cylinder that we have here is 54.4 millimeters in diameter, but this of course can vary in size. So the first thing we need to do is remove the 2 end caps of the cylinder. These serve as a way to help reduce the moisture loss during transportation and storage, but also it's hopefully can reduce the disturbance during transportation as well, just mechanical disturbance. So first we use our screwdriver to remove this. And actually here you can see that there's a borehole log, or like a sheet, and there's some information about where the sample comes from and its borehole number as well as its depth. So here you can see this one comes from 3 to 3.8 meters. So this will be the top will be the 3 meter mark, and 3.8 will be the bottom of the sample. So the first thing you need to do is actually go to your laboratory sheet and note down all this information. So it comes from Flotten, and then note down the borehole number, which is in this particular case 7, as well as the Preven number and the depth. Great. So now we can remove the other end cap, or the bottom end cap, and then we can begin the procedure. So now we're left with this cylinder. I've drawn a little diagram here to hopefully describe to you guys what's inside the cylinder. So basically the cylinder is comprised of the clay sample itself, and up towards the top there's a plug that looks a bit like this. So you can imagine it sits here at the top of the sample, followed by a void section here. So the purpose of this plug is actually to provide some suction inside the cylinder. So hopefully during the extraction process, or when the sample is removed from the ground, this plug will give enough suction to the cylinder so the sample won't just simply slide out when it's removed from the ground. Yep. So here you can see the void up to a point. Great. So the next thing we need to do is actually take some density measurements. So you might remember that density is simply the mass over the volume. So the first thing we need to do is find the mass of the volume of the cylinder. So we can simply just take our cylinder and we can weigh it in the scale. So what is the weight, Micah?
4993.3.
So now we have the mass of the sample with the cylinder. Now we have to find the volume of the sample itself. So if we bring it back here, we can simply find the volume by first measuring the length of the cylinder. So just looking at our sheet before, we can first find the length of the cylinder, and then we can find out how long the void is, and then we can take away the plug. So then we're finally left with the length of the sample, which is this stuff here. So we can just simply take this ruler, and it's around 88 centimeters in length. like this. And then we can measure the void. It's around 6 or so. And we don't know what the length of the plug is right now, so we'll wait until the extraction process is over, and then we can find out the length of the plug. And then finally we can get the overall length of the sample, whatever this is. Great. So now we have the mass and the volume. Well, we have a length, but we can also calculate the volume by multiplying this with the diameter of the sample, which I said before that it's 54.4, which is diameter. Okay. So now we're ready for the extraction process. And the first thing we need to do is to take some of this tape, and we want to close off these holes at the top of the cylinder. This just stops any clay from coming out during the extraction process. Great. Now we can transfer this to the machine itself, extractor. So you might remember this will be the top of the sample, and this will be the bottom of the sample. And it goes through this. So, and you have to make sure it's tight and closed off completely into this nook. So how the machine works is you have, once the cylinder is in place, you have a piston on the left side of the machine, and it applies a force from the head to the bottom of the sample, and hopefully this force will drive this sample out of the cylinder and onto this tray. But you might notice here, this piston head has a slightly smaller diameter than our sample itself. So what we need to do first is to place this head, or this cap, into our sample itself, so that when we apply this piston force into the sample, it's going to be evenly distributed into the sample, and hopefully that will reduce the disturbance during extraction, because the force is evenly distributed. Yep. So to do that, we first have to use our spatula, and we remove some of the clay sample, just so we can fit this inside. Normally there's a different tool for this, but in this particular case, we can just use a spatula, and it should be more or less okay. Because normally we want to have a smooth surface at the bottom of the sample. But for this exercise, this is okay. Great. So once you have the hole, once the hole is big enough, you can place your cap at the bottom of your sample like this. And now we can make contact between the head and the sample itself, or the piston head. Excuse me, Micah. So now we turn on the machine like this. Yep, so now the piston head is in contact with the sample itself. You might be asking, what about the plug inside the sample, or inside the cylinder? If we start pushing the sample now, the plug itself will have some sort of friction and resistance, and it might risk the sample getting squeezed and squished in this general area before it finally gets pushed out. So what we do instead is we have this hook kind of latch. And what we do now is we drive this hook into the sample, find the plug, and we latch onto it. Yep. Okay, so once this is locked onto the plug itself, so when the machine starts and we drive the piston from the bottom, hopefully this plug will get pulled out from the top, and hopefully they move simultaneously in unison with each other, and that will reduce a lot of this disturbance during the extraction process or the damage. And, yep. Now we're ready for extraction, I think. Great. So now we can see the plug, and now we can actually take this plug off. This. And now we can measure this, the length of the plug to find out the eventual length of the sample. Say it's roughly 6-ish, maybe. So now if you look at your sheet, the length of the plug is 6 centimeters. So overall your sample is 76. Hopefully my math is correct. Yes. So now you have the length of the sample, 76. So you can put it onto your sheet here, 76. And you can calculate the volume of the sample by timesing it by the diameter of the sample, which is 54.4. Great, so now you have almost everything you need to calculate the density. Yep. So now we can take this aside. So once you have the plug measured, now we can remove the cap. And now we can remove the cylinder out, so we can measure or weigh the cylinder to calculate the mass of the sample. So we just turn this on. So now we have the piston out. We can remove the cylinder like this. And we can weigh the cylinder with the plug. And Micah, how much is that again?
1946.6.
Great. So Micah, you come back to here. Now we know that. Now we have the mass of the entire sample and cylinder and plug. And now we've also got the mass of the empty cylinder and the plug. So then we can calculate the sample itself. And finally, with the sample and the volume, we can get the mass and the volume to calculate the final density or the average density of the entire sample of this particular cylinder. Yep. Okay, righto. So now we can go back to our sample. And just a reminder, this is going to be the top of the sample, which is the shallow end. And this will be the bottom of the sample, which is the deeper end. And in our particular case, this is 3.76, and this will be 3.0. Now we can move this to the bench. And this concludes the end of the extraction process. Now we can move on to dividing up your sample into 3 parts, and we can start doing the testing on it, and that'll be a different video.